Okay, so now we're going to take a look at absolute value inequalities. So rather than equations, inequalities, okay, I'm going to have the greater than or less than symbols, greater than or equal to, less than or equal to symbols. And a trick that I've learned is that only with absolute value inequalities, and only if the x is on the left. So just remember, x on the left, great or is going to be linked together by the word or, and less than is going to be linked together by the word and. So when I look at an absolute value inequality, 3x plus 4 is great or, I know that this is an or problem, great or than equal to 6. So just like the absolute value equations, when the absolute value is isolated, I'm going to rewrite it twice, once with a positive 6, once with a negative 6, just like the absolute value equations. For the positive side, I'm going to keep the sign the same. For the negative sign, I'm always going to flip the sign. So notice that I flipped the direction of that inequality symbol. And in between the two statements, in between the two inequalities, I'm going to have a linking word of or. I'm going to go ahead and solve these. So x is greater than or equal to 2/3. And then x is less than or equal to negative 10/3. And this is an or inequality. So I'm going to go on my number line, and negative 10/3 is almost negative 3. It's a little bit above negative 3. It's a bit less than negative 4. And 2/3 is almost at 1. It's a bit farther away from 0. I'm going to have a closed circle at negative 10/3. Shade to the left. I'm going to have a closed circle at 2/3 and shade to the right. And this is an or inequality. So this is my solution, and this would be my graph. Remember, for or inequalities, I don't have to worry about where they overlap. So looking at the 2x minus 1 is less than, okay, remember that that is an and, less than 7. Same idea, 2x minus 1 is less than 7, and 2x minus 1 is greater than negative 7. So notice how when I wrote the negative, I flipped the sign. Going to go ahead and solve. So x is less than 4, and x is greater than negative 3. Remember that this is and I can smush these together so I can make one inequality statement. If I'm really savvy here, x is greater than negative 3, x is also less than 4. I'm going to go to my number line, 0, negative 2, negative 3, negative 4, and then 3, 4, 5. Open circle at negative 3, open circle at 4. X is less than 4 means essentially I'm shading that way. X is greater than negative 3 means I'm shading that way. The overlap, since this is an and problem, is in between the two. So in this case, this would be my solution, and that would be my graph. Okay, let's try another greater than. So I'm going to rewrite it. It's greater than negative 1, or 2x plus 3 is less than positive 1. I'll go ahead and solve. So x is greater than negative 2. X is less than negative 1. This is or. On my number line, 0, negative 1, negative 2, negative 3. X is greater than negative 2 is open circle and to the right. X is less than negative 1 is open circle and to the left. And looking very carefully, what I've noticed for this or problem is that everything is shaded. Everything has been overlapped somewhere. Everything has been shaded somewhere, not overlapped, shaded somewhere. This solution is all reals. And if I go back to the original problem and think about it, think about distance and negative. We talked about in the absolute value equation video that distance can never be negative. Distance is always positive. And since distances are positive, or 0, and positives are greater than negatives, we knew from the very start that this was going to be true. It was always going to happen. This is an always true inequality. See if you can catch what's going on with this problem before I start trying to solve it. I'm going to pretend like nothing's going on here and I'm not paying any attention, and I'm just going to go ahead and solve the problem. Changing the sign, flipping the symbol, including the and, because this is a less than problem. Actually, a less than or equal to problem. So I have x is greater than or equal to 8. Gonna have to smush this together. So I have x is less than or equal to 8, or greater than or equal to 8, which is to the right of 8, and I have x is less than or equal to 4, which is to the left of 4. And this is and there's no overlap. Remember I said at the beginning that there was something going on here. When is a distance going to be less than any negative number? Never. There's no overlap. There's no solution. Okay? This is going to be an example of an inequality that is never true.